So my talk today is on water as a driver for design. Right? When I talk about design, I'm actually today specifically relating to urban design, design within our environment. Like most of the design we do, what we look at for are the main trends that is affecting mankind. So the 5 main drivers that we typically look at is demographic change, urbanization, climate change, natural resource shortages, and globalization. So for today's topic, the 2 main trends that has got especially pertinent is urbanization and climate change. This is a chart of how population has changed through the years, right? The world's population has really exploded, right, over the last 50 years. And because of this explosion in population, right, the migration patterns have changed. And we notice the chart on the top right-hand corner, right, is showing Singapore's transition from a primarily primary forest to a largely urban development, right? And the bottom picture will show you that, you know, in the traditional cities, this really migration is related in dense urban developments where people live in high intensity vertical buildings. And this has really led to significant change in the way water has manifested itself in our natural environment. In a traditional, a natural environment, right, you have most of the water infiltrating into the soil and being uptaken into the by the organic matter and by trees and plants, right? And this leads to a water loss through evaporation, right? A small percentage of it finds its way via runoff on the surface. But due to this change in our environment, right, increasing urbanization and build up of our cities, the water regime has actually changed, right, from a much lower amount of evaporation because, you know, there's much less water uptake by vegetation. So as a result, runoff is becoming much more a factor within urban environments. And this is highlighted in the red segment shown on the right. So what does this mean with this higher rate of runoff? It means that water stays on the surface, right, moves through our environment much quicker, right, and put a much more tremendous stress on our urban infrastructures. So how do we do it, or how have we been dealing with it, right? So what we have done is, you know, we put all together our engineering minds and come up with ways to get rid of this water, right? Convey it, like in this case, underground, hidden away in pipes, or on the surface as large gray engineering infrastructures, right? And most of these are designed as monofunctional elements, not really accommodating the needs of biodiversity, not really engaging man, keeping water separate from the places we live, right? And this has led to problems, right? Because these infrastructures are fixed, right? They're not really adaptable to changing economic climate, and the benefits are limited to just conveying of water. So a lot of these infrastructures actually has been degraded through the years. The upkeep is expensive, right? And it's also a place to be forgotten because you know, people use this as a place where they can dump the garbage, right? The polluted, the water there is extremely polluted in many cities, right? And the surrounding neighborhoods and residents are not benefiting from the infrastructure. this has become the backyard, right? A place to be forgotten, only for to getting rid of garbage, getting rid of water, which is unfortunate because water as a resource is extremely valuable, not just for drinking, but to sustain our natural environment, right? To provide a space for respite, right? To enhance the quality of our lives. So the climate change due to man's actions has added stress to these urban infrastructures that we have built over the last few decades. This has led to increasing rates of flooding. If you look at this particular chart, right, there's the green line represents natural peak flows you find in a natural environment like a river. Right? And the peak flows are much lower because a lot of the water is infiltrated after rain, storm events, right? And slowly discharged into our natural systems, and majority of them is lost through evaporation. But because we have changed the water regime, now evaporation plays a much lower role, right? And runoff plays a much higher role. So the impact, right, after rain is much higher. If you look at the urbanized peak lows, peak highs shown in this chart, you'll see that immediately after a storm event, there's a spike, right, in the volume of water flowing through urban spaces. These peaks put a tremendous stress on gray infrastructure that has been designed and built for a different time where the storm events are much lower. So that's why we are seeing increasing rates of flooding all over the world, right, including developed cities. So there's really a big need to relook at the way we use water or consider water when we design our urban environments. And this is demonstrated, for example, in 2011, even in cities like Copenhagen, right? Copenhagen is actually an old city that was designed more than 100 years ago. The drains and the roads were all designed for a different era. So with this recent climate change, it has really stressed the public spaces, and demonstrated by this particular event, which really cost billions of dollars. It is not just a problem for modern, heavily built up cities, but even the cities in less developed countries face the same. And the problem is also compounded by the fact that due to ice melting in our polar caps, right, we've got much stronger storm surges that's coming in from the sea, right? So the combination of the heavier storm events and the storm surges from the sea, right, really creates extremely dangerous environment for our cities. This is a visual explanation of what is happening today when it rains. When it rains in our urban environment, our immediate reaction is to try to collect this water quickly, try to convey it, right, through a central canal, and then try to discharge it into the sea. And it's all this in effect of trying to get rid of water out of our environment. So in section, this is how it looks, right? It rains and quickly discharge. And this, fills up the canals. While this used to work, but because of the increasing runoff rates from urbanization, there's the gray infrastructure we have designed many decades ago is no longer able to accommodate these new peak flows. So we really need to shift the way we think. We need to look for a new paradigm, and that involves looking at how we can work differently with water within the environment. So in this new paradigm, what we need to do is to see how we can retain water on site where it falls. And then slowly release this water, manage the release through natural systems or design natural systems, retaining longer within the environment, right? The act of retaining it within this environment will also allow us to clean the water as it moves through these systems. With this clean water can be released into an enhanced waterway, like a naturalized canal, right? That looks like a river, much like Bishan Park, where the benefits are a lot more visible and much more multifunctional in nature. And this slow release of the water can be used to enhance the environment around these waterways, finally ending up in the sea. And Singapore has taken up a step further by impounding these rivers, right, and making them in effect into freshwater reservoirs. So then this water now is available for recycling, right? Whether it's for public use or even as drinking water. Ultimately, some of it becomes new water for us, or treated water for home use. So water as a resources then can be used in multiple ways, right? In infinite cycles, which in an environment like Singapore, which is density like Singapore, is a very, very valuable resource. So in section, this new paradigm involves looking at how we manage water in a three-dimensional manner, starting from the roof of buildings, bring it down, using it as it moves through the vertical surface of buildings, down into the ground, retaining it, cleaning it, before finally discharging it in naturalized waterways. So how do we make all this happen as designers, as planners? I think the first thing we need to do is really change the mindset of how we regard water and treat water in our planning and our design. So the next section I want to talk about is rethinking design, rethinking the relevance of water. It begins with an appreciation of the special characteristics of water, right? This is a really old photo of members of our studio in Germany, where we are doing a water experiment. An old colleague of mine holding this big brush, running it through this body of water, right? And showing how water actually behaves in manner that's surprising. So what he has done is actually sprinkle some really small fern seeds onto this water, still body of water, and running a brush through this thin layer of seeds floating on the surface. And what you get is these really beautiful patterns, right? Naturally created by this movement of water within this, by this act of moving the brush through the water. So there's a beauty to water that's sometimes forgotten, right? And as designers, as planners, it is really urgent for us to reveal this beauty, this inherent beauty, right, and value of water. The simple act of designing a drain outlet can convey a lot about this element, how water moves through our surface, instead of putting it into really functional, straight linear drains to be forgotten, why not make it into a beautiful element that is playful, that's thought-provoking? As a public user, if I see this as opposed to a drain, you know, it's a lot more educational. I'll be a lot more engaged. I'll be wondering, you know, wow, where does this lead to? You know, and understanding that this is part of a wider system. This is the way we traditionally design our conveyance system. Gray concrete canals, separated by fences, right? Acting as an obstacle between communities. I think we can do a better job as designers. I think we can make that into spaces that connect communities, bringing communities together, allowing for nature to flourish. But at the same time, not having to sacrifice the part about conveyancing and being able to accommodate and incorporate cleansing elements. So instead of just a monofunctional design, it becomes a multifunctional design that has an impact on the quantity of water, quality of water, habitat for urban spaces, and a connector for community. We take a lot of inspiration from natural systems, right? So this is an example of a delta design. We were looking at how we can maybe help to clean or clarify water coming down from streams that's heavily sedimented, right? And looking at natural delta systems that we find in nature, we create a series of models to simulate how these can help to promote sedimentation. So nature is a big source of inspiration for how our relationship with water and how we deal with it. And this is one of the final outcomes of this delta design. It's an abstracted, obviously it's an abstracted form of this delta design, right? But with the intention of really clarifying the water that comes from upstream. We have been working extensively with the PUB for many years on this program called ABC Waters in Singapore. And really this program revolves around how we can better manage water within our public spaces. But the end result we are trying to achieve is really to change the mindset of people, right? How we behave around water, right? And how we can use the element of water to moderate and affects people's impression and a sense of ownership towards water. And this really starts with planning, right? Planning the whole process of how water moves through the environment, from the time it falls on the top of buildings, its movement through the parks and the roads and the cityscapes, and finally how it ends up in our rivers, in our ponds. So the diagram actually, encapsulates this whole concept of ABC, which is it rains, you collect it in many different sources as possible, from the roof all the way to the ground, right? And we try to incorporate cleaning elements in all these different sources. With this clean water, you use to beautify all the surfaces, right? Water bodies, our places where we live, our waterways. And with these more beautiful places, then we can allow people to program it or colonize these spaces for activities. Right? And the act in carrying out social interaction, playing, right, being educated in this beautiful environment will hopefully engender a sense of ownership, and that's the whole point, right? Only then can we change the way we look at water, right? The way we act around water, and the way we would preserve this very important element. Water is prevalent within our environment everywhere, even within existing urban fabrics. So there's a lot of opportunity within existing fabrics to accommodate new ways of looking at water and managing water. In this particular slide, it shows, the buildings, the parks, roads, the plazas are all potential areas where a planner or an architect or a landscape designer can think about how we accommodate this element. In a building type, in a building, there's an opportunity within a three-dimensional envelope of a building to, for example, incorporate a roof, a green roof, vertical greenery, or swales around the apron of the buildings. In car parks, instead of building underground drains, you can incorporate swales to catch the runoff from cars, and this can also act as a pre-filter for example, from pollutants that is being discharged from cars. In plazas, the runoff from around the buildings can be collected, cleaned in a wetland, and then have the water uptake by trees. This act of evaporation can cool the surrounding environment. And then in parks, right, where water from all these urban areas can be discharged, right? We can, instead of having canals, we can naturalize it into rivers, make it into a living, breathing systems, providing spaces for people to interact and to build memories. So when we think about water, you really need to think about it in terms of systems, right? Water is, unlike a lot of the design elements, they are not static, they are dynamic and ever-changing. They move through the systems, right? And the act of moving through the systems actually changed our environment. So one of the ways of dealing as a designer is to really think in terms of modules, right? In this case, we were working for the government in advising them about how we can deploy water-sensitive urban design, right, within larger precincts. And we created a series of toolboxes. In this slide, showing things like green roofs, facade planters, perimeter detention, floodplains, and a lot. And these are then used as modules and pieced together in different ways, depending on the site environment. So they don't act as individual tools, but they act in concert with each other as a complete treatment train, right? All the way in three-dimensional space, from the top of the building all the way to the sea. All of them performing different functions. This gives you flexibility of responding to the site, right? And it also allows you to scale up to larger sites. And that's where you have the largest impact. When designing and planning your water, you can plan for a small plot, but the impact you have is not significant, right? For an element like water to have significant impact, you really need to look at it at a much larger scale. Being able to scale up your design to have a significant impact to a much larger group of users. So the toolbox was that I showed you earlier was pieced together in different ways to form treatment trains, which are then deployed into a larger precinct, each having different levels of impact on the individual development plots. So the way now we're designing water is no longer monofunctional in nature with this new proposal, right? As opposed to a canal where the only intention is to convey water. Now, if you create this multifunctional approach, looking at different aspects of water, you can have an impact, not just on conveying. Yeah, you can have an impact on how people use the space, on the aesthetics of the space. You can have an impact on nature. You can have an impact on health and education, and a whole host of other benefits. So this thinking in systems allow us to have a multifunctional, multi-layered benefit to designing and planning. Now I'd like to take the next part of the lecture and talk about two case studies that incorporates this design thinking and looking at how we use water as a driver for design. This first case study is an unnamed WSUD district that we did for a client here in Singapore. It's a large undeveloped area in a very prominent site. And the client wanted to see how we can use water, right, as the organizing element, as a frame for the for this new development. So it starts with understanding how water moves through urban spaces. From the roof, understanding where we can the opportunities to collect, to clean, to detain, to recycle, and finally to discharge into public systems. So this was the original plan we received from our client, and if you look at it, this plan is actually guided by the road, right? The circular road. Everything is shaped around this road, right? In this case, the vehicles are prioritized. The vehicles are ever present and visible, and dictates everything around it. So one of the first acts was to see how we can de-emphasize the dominance of this road, right? And prioritize livability. So this was the plan that was ultimately proposed. And in this case, we actually reduced the extent of the road, right? Put some of it underground and made the landscape the center of this development. And then also, in fact, creating spaces for water to flow freely from the development plots into the river. But it's much more than just a rezoning of uses, right? The impact on how you perceive the development, the impact on the user, the livability of the space. So instead of having to watch out for traffic, constantly having to deal with moving vehicles, having to wait to cross roads, being visually impacted by the vehicles. Now you have the opportunity to be away from traffic, to live within a garden, to have free movement to the waterfront, right? To have flowing water that's uninterrupted, to be much more connected, right, to the place you live. It's a much more livable design. So it really starts with the green and blue infrastructure. In this plan, that's the start point. We use that as a frame to define everything else, right? We've created this green corridor that connected the MRT station in one corner to the riverfront. Along this corridor is where we embed water-sensitive urban design, the treatment train, the swales, the detention ponds and all, so that they can flow contiguously along this linear green corridor. And then after that, development plots are then defined around it, subdivided, and ultimately the buildings goes around this. So it really starts with the green and blue infrastructure in this plan. So with this green and blue as an organizing element, then we can we define the places of buildings, the density of the buildings, right? The separation and the position. Much more free to place the buildings within this much larger garden space, and the connection to the river is seamless and integrated. And this is a plan showing our final proposal. And compared to the original plan, it's a lot greener, a lot more livable, much more closer integrated with the river and the water that falls on all these plots. So one of the key drivers was really to make water extremely visible to all the residents and users of this space, so that we use water to brand this new development. So a rendering of what the green spaces, right, is where you typically find a road running through, but now the road is gone. In place, it is now a green park, providing a lot more opportunities for recreation, enhancing the value for biophilia, and also enhancing the property values around it. What typically would be concrete drains are now beautiful landscape bio-retention swales in place of drains. And because they are landscape, they blend seamlessly around with the surroundings. Circulation pathways that incorporates engineered design for water sensitive elements. The act of rain, right, channeled into these landscape trenches that acts as infiltration beds, cleans the water as it moves through the system before it's finally discharged into the public systems. So all this design is, in effect, what we're trying to do is bring back some of the natural process, some of the processes we find in nature, trying to find a balance between infiltration, evaporation, and runoff. Trying to look for opportunities to reuse water, to reduce runoff, to clean water, and to use water as a commodity to enhance livability. The thing about working in water is you need to understand the character of water. You need to be precise, right? Water is very unforgiving as an element. If you get it wrong, for example, if you sized a swale wrongly, then there's a potential for flood or for backup. So we need to know what how big we need to design it, how fast the water need to flow, what kind of water quality we are trying to achieve on discharge. So it's important to understand the requirements, right? In this particular plot, for example, specific requirements for discharge rate. We want it as a demonstration space to show that it is possible within a public space to slow down the discharge of surface water, to hold back water, to be able to accommodate larger storm events, reduce the runoff rates, and improve, for example, water recycling, and ultimately the quality of the water. All this is possible, even within heavily built urban areas. The integration of water, be it from the private to public space, is important because, as I mentioned earlier, water is a dynamic element. It does not stay in one spot, right? It moves through the urban space. So it is really important to think about how you integrate this movement through the different private and public landscapes. So in this particular development, we had to write specific guidelines that enable the private developers to work with public authorities so that the water's movement is not impeded, is seamless, and is coordinated. We designed for specific runoffs, hoping to achieve the same runoff rate as what we will find in greenfield systems, right? As opposed to a typical urban systems where the runoff coefficient is 0.8. We wanted to achieve a post-development runoff of 0.45, much closer to nature areas. This will help reduce the discharge into canals or rivers, and therefore leading to less stress during storm events on these public infrastructures. So this is at a precinct level, at a development plot level, how we view one plot. From this one plot, the same element, for example, collecting water on the roof of buildings, right, and conveying it down the buildings, is then deployed over the entire precinct. And the water is just discharged into swales where there's some pre-cleaning going on. And then this clean water is detained in either surface ponds or underground detention. And then it's further discharged into the public space. very visible flowing water on swales, bioretention swales and streams, and then collected into ponds, right? And these ponds, detention ponds, can be used to define nodes, special nodes, and animate more high-profile public areas before it's finally discharged into the surrounding river or recycled for more use, for irrigation, for car washing, or any other functions. We also look at how we can incorporate, the bioretention swales all along these public spaces, making them visible, using them to animate surface, and promoting interaction with water. Roads takes up a lot of space, right? And we also need to consider how we engage with water, and the water that falls on the road is collected and treated, and then made into usable water again. But these elements can be beautiful. It can look as part of the surrounding landscape, even though it's a technical system that is used to treat water. I mentioned that water is dynamic, right? And therefore, it gives you the opportunities to create multifunctional spaces. So through the different storm events, right, you can have a small stream in a normal dry weather flow, but this stream can expand exponentially in width to accommodate, encompass a much wider area during an extreme storm event. So as planners and designers, you need to accommodate for this dynamic nature of water, providing spaces for it to expand and contract. The buildings are actually opportunities to create three-dimensional spaces, right? For the green infrastructure, in this case, from roof gardens down all the way to the ground. But also within these green spaces, you can incorporate water-sensitive urban design, right? For example, on the green roofs, you can have subsurface collection and storage of water. As it moves down the vertical surface, you can have cleansing all along the way and irrigation. And finally, you can detain it under the building or as exposed ponds, right? And then use it to animate the surface, beautify the surroundings, and moving it towards the public discharge. Next, I'd like to talk on a wider scale. So in this case, this is a city scale development in China. Specifically, this particular development is in Guangzhou. It is part of the very large Pearl River watershed, right? And Guangzhou is really near the delta of this watershed. This whole watershed encompasses a variety of environments, all the way from mountain to the delta and everything else in between. Because of this huge variety of environments, there's rich biodiversity, right? And a lot of unique qualities with potential to add to the quality of this development. Guangzhou itself is positioned very close to Macau and Hong Kong. So it's got really significant strategic relevance, right? And a potential to really be a global player. It has got really strong cultural identity rooted in the Linan culture. We all know that it is also a factory to the world, right? Producing a huge percentage of the emerging technologies handphones and telecommunication equipment. But unfortunately, it's well, it can be just both of disadvantage and advantage, but it's situated in a very flood-prone delta area. It has, from climate change perspective, right, it is really suffering the effects. So this series of charts actually show, series of maps, heat maps actually show how the Guangzhou has been affected by climate change, how the heat island effect has really slowly spread through this area. So much so that now currently the urban areas is 3 degrees hotter than the rural areas. So it is situated near the confluence of multiple rivers near the delta. Which means that a lot of water that falls on the entire watershed is being channeled through this bottleneck. As a result, through the years, right, flooding is becoming a bigger problem. Actually, the flood-prone areas have multiplied 100-folds from the 1980s to the current situation. And this is exacerbated by the fact that, stormwater surges. The deltas are naturally low-lying areas. Deltas are areas that's created by sediments brought in by the river from upstream, right? And they tend to be low-lying, very prone to flood from the rainfall that is coming down. But because of climate change and melting ice caps, the water levels from the sea is also rising. So there's pressure from inland and pressure from the sea. And the average level of this delta is 1 meter above the surrounding water bodies, creating tremendous pressure during high tide and in extreme storm events. A survey done by an international institution showed that Guangzhou actually ranked the highest in terms of risk profile for major cities that's exposed to flood. And the risk is significant. So if it aspires to be a global city, right, that is befitting its wealth and its culture, then the city really needs to rethink the way it designs for water or design to accommodate water within the environment. And so we were invited for this, we were given this project to see how we can use water to drive the design. They did a few master plans previously for this really important study area in downtown Guangzhou. But they weren't really happy with it because it really didn't address the critical problems going forward. So one of the first things we really did was study the water, study all the water bodies, study how water moves through the city, and using it as the main driver to frame the entire development, how the city is structured. So there's a variety of spaces. There's the reservoir in the north, and there's the green corridor, and and all this is linked by this extensive network of waterways that is really quite common in delta areas. And we use the existing waterways to see how we can create unique spaces. By enhancing these waterways, you also extend the opportunities for riverfront living. And if it is designed well, this riverfront is extremely livable, some of the most valuable real estates, as opposed to a canal to be ignored. Looking for different areas, combination of areas with different qualities, to create spaces for different facilities and communities. Looking at how we can link the downtown, right, to the center of the city, creating this corridor that can help to brand the city as a gateway for Pearl Delta. And then after that, with this framing using the waters, using and how we can propose the different zones with different identities. So our design concept actually started with this sketch, and this sketch really encapsulates our thinking, putting water front and center, connecting the interior of the city with the major river in front, using this new green and blue infrastructure to brand the city. And then incorporating the economic needs as the next layer, and the cultural needs, paying homage to the Leonard culture and making integral part of this modern city. And finally, linking all these via green corridors. And then the vehicular traffic and the green connectors that connects the rest of the city fabric to this larger green network. And this is the final plan. It is actually a Pearl Delta design in mini, right? Really symbolic for this area, but at the same time, it's a really strong statement to how we use water as the main driver for urban planning, making it central to the identity and functioning of this new development. These are the different zones that set up after the initial concept was done, always focused around the green, blue, and blue infrastructure. And then looking at how we incorporate all the most important elements, the culture, the climate, and economy, as a seamless experience that binds the city together. And then thinking about human circulation through all these spaces. And then finally, really relegating the vehicular circulation as more a supporting element. So the design strategy really starts with the water, right? And the dynamic nature of water as it moves through urban environment. Then next, that's followed by how we can include the landscape element in concert with the water, how we can link the waterfront, then how we can use these new structures to accommodate pedestrian flows. After we figure out the pedestrian flows, then we look at where we can put in nodes within these movement areas. And then finally ends with buildings, where the buildings are positioned. So this sequence of strategy actually is very much reverse in a lot of way urban planning is done, where they are looking at the circulation first and then looking at position of buildings. We're actually starting from water first, landscape, before finally ending with position of buildings. It really requires a paradigm shift in the way you do urban planning. traditional urban planning. So from the water perspective, there are many important considerations: how we connect all the different water systems and the subsystems, how we allow them to move, right? And it starts with understanding these issues. What are we up against, right? Are we up against flooding? We are against storm surges. We are up against melting polar caps. We are up against destruction of existing habitats, right? And if we don't act, what are the risks? The risk is, decrease in livability, natural disasters, homes are at risk, economic loss due to flooding, right, affecting the economy. So with this in mind, then we figure out what we can do using blue and green infrastructure, right? How this green and blue infrastructure can help in building livable cities that is future adapted and resilient. Understanding each of these risks, specifically what type of flooding, how often do they happen, what sea level rise threat over the next few decades. So it's not just designing for the present, but designing for far into the future, helping to alleviate heat island effect using this green and blue infrastructure. So we look at this as opportunities. All these issues and problems that was defined earlier are all potential opportunities if using this new approach in planning. So the combination of flooding, pollution, low evaporation, rising sea water level, what we are saying here is green and blue infrastructure solutions offer you an opportunity to address all these problems to different degrees. Instead of having to look for monofunctional engineering solutions, you can address multi-layered issues using this new design approach. So for example, embedding this green infrastructure and making it pervasive throughout the city, from the buildings to the ground. In this case, showing how we can affect cooling by having greeneries on top, by having water, reduce the heat load. Having vertical greenery on the buildings can help to uptake of polluted air. Greenery acts as green buffer and also places for biodiversity and recreation. Very, very multifunctional in its solution. Stormwater management, how it can incorporate within the fabric of this new city. But this is only possible if this is done as a deliberate effort, very start of the master plan, right? When the planners look at it, you must start thinking about it now and not only considering it later on. Because if you have to retrofit these processes into a traditional design, it's not going to work as efficiently. Looking at how we can enhance the value of these elements by not just using them once and cleaning and using them once, but using them on multiple occasions over and over again. And having these systems embedded into the urban environment gives you this opportunity. Looking at studies on how we can, structure these spaces, structure these infrastructures to help, for example, moderate the wind or divert the wind to affect how we perceive thermal comfort, how it relates to cooling, how we can use water and greenery to help in cooling of buildings. and then looking to uptake carbon and pollutants. So what we are trying to do is create value for the city that's multi-layered and that's diverse. And ultimately, right, it does not have to cost more. In fact, based on our life cycle studies, it adds, ultimately everybody benefits. The net effect of all these investments is a huge positive. This is verified by the studies we did, especially for the first project I showed you, where we involved some financial advisors to look at the cost of all these green and blue infrastructures, right? But all the quantifiable and non-quantifiable benefits that occurs from this investment. And it shows that over the life cycle of this investment, the benefits far outweigh the cost. So the whole idea is to create this new future forward city in Guangzhou, right? That is in keeping with its economic and political aspirations. I mentioned earlier that it's really important to be very rigorous when you're thinking about water. You really need to understand how water works, right? How water moves through surfaces. So in this case, we really did extensive study on catchment areas, really understand how water moves and how we can use these tools to treat the water at different areas in treatment trains, how we can connect them as one system. Right? And how we will look, right, as it moves through, what are the different technical elements that is required to make to realize this. We also did modeling for different storm events. There's one 10-year storm event, that's a 50-year storm event, and there's a 100-year storm event. And it's important because then you can plan for it, right? We are not reacting. It is planned, we are proacting, and we are designed to accommodate these different storm events. And ultimately, really creating livable spaces for people, for users, understanding how this can be a resilient environment reacting to climatic changes, and really using it to define the city. This is a section of how the main corridor that looks that connects the city center to the sea. Finally, ending with the Bayfront strategy. So the end point of all this green and blue infrastructure actually is the riverfront. And this is where we really have this iconic image to brand the city. But it's not just an iconic image, it's actually a functioning system that serves to hold the river back from sea level rise. So these new areas are actually separated from the new river, The water that flows from the inner city is collected and controlled, and the water can be recycled. The river front is protected using a typology of embankment strategies that works during dry and also during storm events. And finally, when all this green infrastructure is designed, we then define where the spaces for the architecture, for the building blocks. So this is a series of diagrams showing the conceptualization of the central space, the forms that goes around this central space, and the green corridor, how this is all used and work in concert each other to define this space, and ultimately how it lies within the city. The position and the scale all relate to each other. And the skyline, how the skyline actually will draw the central corridor and highlight the central axis for the city. The final building forms that's really sympathetic to this central corridor. So with that, I end my presentation. Thank you all for your attention.